You can't go through life without encountering geometry. It's in buildings and architecture, it's in arts, it's just in the space that we live in the universe. So I'm interested in understanding geometry and how these things fit together. I'm Dr. Jessica Purcell from the School of Mathematics. The types of math problems that I liked at school were the ones where you got to figure out answers on your own. It's not where they gave you something and said, do it this way, but they were open-ended and you got to figure out what was going on. I love understanding, to be able to find new patterns and to understand how different areas of mathematics work together. I like the challenge of being able to understand new problems. My area of research is in three-dimensional geometry. So it studies the type of spaces where when you're standing inside of them, everything looks three-dimensional. These particular spaces usually, although they look three-dimensional, if you stand back, they unfold into higher than 3 dimensions. And so it's harder to get a global picture of what they look like. And we try and understand and classify these spaces. One way to study them is to chop them up into pieces that are much simpler, such as tetrahedra, which are three-dimensional triangles. Recently, I have been studying how tetrahedra glue together to form different spaces, or how spaces decompose into tetrahedra. And I'm able to use this as a way of measuring the complexity of a space and also to measure how spaces deform. In my research, I've been investigating ways of stacking tetrahedra that come from patterns of fractions that were first studied in the early 1800s. And by stacking these fractions in this way, we've been able to relate this to a polynomial that encodes how certain spaces deform. So we found connections on the one hand between the fractions and on the other between the polynomials and these geometric spaces. These connections occur all over in mathematics, and they're very intriguing. And our research tries to understand why and where and how they arise. My ultimate goal for my research is to be able to increase our understanding of spaces and the universe a little bit more, and also to be able to communicate with other people so that together we can further our knowledge.